Hello everyone, this is our thread scheduling project. In addition, we also added two problems related to logs. This is our program interface, which we made with Java Swing. The first is time display and time zone switching. We set two threads to display the time in different time zones and use suspend and resume method to control the thread post and start. Then we use whether the button can be collected to limit whether the current time zone can be switched. But at that time, these two threads were actually running all the time. This is the final effect.
There are three buttons corresponding to the start, pause, and reset stopwatch function. This is the implementation of the associated source code. Here you can see that the stopwatch thread belongs to the myThread2 class and has been running since it was created. The pause and the reset action simply uses the suspend method in the thread to suspend the thread, but the thread is still running after it has been suspended. With the Eclipse plugin G0VM, we can see the running state of the thread, and we can see that the thread is always running.
Next one is our countdown tools. This is our drive view, and you can see mainly four buttons and three spanners tools in our UI. And the countdown tool is mainly based on the stopwatch function. In fact, its logic is the convert stopwatch. So the task is completed by my3 class, but we need to set its initial values as the time when the countdown watch starts. This is a way to use our countdown tools. The first step is input time in spanner and click the confirm button to set the countdown watch. And second step is click start button to start the countdown watch. You can see the test panel is running. And second step is click halt. If you want, we can stop the time. And the finally step is click our reset button to reset all the time. So in this step, we can back to the step one to start a new countdown.
In this alarm section, each time we click the button and the alarm thread will be created. And we count the waiting time and put it to sleep. Then trigger the pop-up windows when we wake up. And at the same time, the time thread should be kept for readers to reference. For the sleeping part of the thread, we get the value in the spinner and minus the time we got from the date method to get the waiting time. And the color and text will be preserved after the window is closed. For the panel design section, we need two panels that run independently. So first we need to declare a new panel and make it invisible. And which with each click, make sure that the time panel is shrunk. Notice that this access allow is a global value that act as a signal. And there are two types of click events. When the signal is false, the thread skips this section and makes the panel visible and change text to uh, alarm mode and convert the signal. When the signal is true, we get the spinner alarm text and fill in the prepared priority queue and print it out on the panel. So for the quit button, the perform value and the signal initialization and the time panel restoration should be performed. Next question is about animal eating problem. We create two threads named cat and dog and add logs. Generally, it can be understood that thread that grabs the log will eat first. If it finds that it is not what it like to eat, it notify another thread and then wait. If it like to eat it and then notify another thread. They start to grab it again. This is a loop until you find that there's nothing in the list and notify each other to end the thread. This is a visualization of threads in JVisual VM.
The solution to the philosopher's eating problem we are using here is that a philosopher can only eat when both chopsticks are available. Our idea is put the thread to sleep while the philosopher is eating or thinking and print the philosopher's ongoing activity on the console. How to hold chopsticks as long as one chopstick is already occupied. Give up holding chopsticks and release the lock to enter the waiting state. When notified, it enters the ready state and recompetes for the lock. Declare that the chopstick is occupied when you get it. When the chopstick is put down, it also applies for the lock and then notifies all waiting threads that the lock has been released and so on.